Hello class, this is combining transformations part 2. So in the previous video, we saw how to apply transformations as shown here. But now, rather than a listed instruction, we're going to apply transformations that look like this. And in order to do this, this is a best way to do this. It's best to recognize transformations in the order dilations and reflections first, and then translations. And we should always apply vertical transformations first. Also, when working with multiplicative transformations, so dilations or reflections, it's best to factor the transformation to have an x coefficient of 1, because this will be particularly useful when recognizing horizontal translations. So let's actually get into some examples of what we mean. So here we have a function given to us. Rather than being told do, like for example, rather than being told do this transformation and then do this transformation, we're simply shown finish this. Well, applying this, let's recognize what has happened first. X minus 1, well, that is a horizontal translation, 1 unit to the right, and this plus 4, that's a vertical translation, 4 units up. Now the order in which we do this, okay, if you can remember about the commutative property, because these are both translations, it doesn't matter which order we do it. So in actual fact, you might be able to do them at the same time. It will look like this. Y equals, I'm going to write this out as 2x minus 3. So notice how I'm letting y equal 2x minus 3, 2x minus 3. And then I'm going to write in that plus 4 for our transformation. And now inside of x, we're going to write that transformation x minus 1. Simplifying this, we will get 2x minus 2. Simplifying these two, we get plus 1. Collecting like terms, we get 2x plus 1. So this is the expression for this one. So we've applied the transformations shown here. Let's move on to the next one. For this, if you can recall, it's best to factorize this first. So this will become f of x equals x plus 3 minus 5. So now that we have this, let's recognize the two transformations first. X becoming negative x, because x is becoming negative x. That is a horizontal reflection, or reflect, on y-axis. You can also write a horizontal reflection. And minus 2, now remember, this results from y plus 2 equals f of x. It's only minus 2 because we've moved it from the side of y. That is a translation, a vertical translation. We can just write translate 2 units down. Now if you can recall, since this is a horizontal reflection and this is a vertical translation, the order in which this happens, it won't matter. So for this, we're going to substitute negative x for x in our expression. So we get y equals, it'll become negative x plus 3, substituting negative x here, and then negative x minus 5. That negative 2 is going to be included into the end. And so from here, we can simplify this expression. Factoring out -1 from this group, we get negative x minus 3 times, factoring out a negative from this group, we get negative outside of x plus 5 minus 2. These two negatives are multiplying to become positive, which ends us with x minus 3, x plus 5 minus 2. For this exercise, we're going to leave it as it is, because expanding this is going to just make it more difficult for us later. Okay, so let's move on and let's keep applying these transformations as shown in this form. Okay, let's move on. For this one, once again, should always factor where possible. I can see we can factor out an x in that f of x, so let's write this out first. X outside of x squared plus x minus 2. So from this expression, I factor out x, and inside this group, we can factor out further. That's a positive 2 and negative 1. Oh, yep, that's right. Okay, now from here, let's recognize the two transformations happening. Negative f of x, which, if you can recall, that will happen from negative y equals f of x. That's a vertical translation, a vertical reflection. And this is 3 units to the right. So we have two transformation. It's a vertical reflection and a translation 3 units to the right. Okay, so applying this to our expression, a vertical reflection will be negative y equals, and applying this negative 3 to each of these x values, we get x minus 3 outside of x minus 3 plus 2. That's this next group, times x minus 3 minus 1. So notice how we've kept the negative y here so that we can multiply it back later on. So this will become negative outside of this x minus 3 remains the same. This group will become negative 3 plus 2 is x minus 1. Negative 3 minus 1 becomes x minus 4. So our final transform group is this one. Obviously, we're definitely not going to be expanding this expression. All right, so that's just the first 3 examples here. Let's cut the video at this point. I'll see you in the next set where we take on the next 5 examples. Okay, hope to see you then, and best of luck.